Okay, day 2, machine learning. Let's go. So review. What is a machine learning algorithm? Okay, take a moment to think about that. And also take a moment to, what are 3 types of machine learning algorithms? The 3 types. And which of the 3 are we going to focus on? So when it comes to machine learning algorithm, machine learning is for us to be able to make predictions. Okay, we're trying to make predictions and trying to more so use the computer to help us make predictions. And an algorithm is a recipe. It's a process, a procedure for us to make prediction to be able to make predictions. And the 3 different types that we talked about yesterday are supervised learning, unsupervised learning, and reinforcement learning. And we're going to focus primarily on supervised learning. And so with that being the case, within supervised learning, if you look at the image that we referenced yesterday from that one website, I think it's called Data Lore, there's 2 different types of supervised learning. When the response variable is quantitative, we consider that to be regression, and when the response variable is categorical, or categorical binary, we consider that to be classification. So regression, I'm trying to predict your GPA, or I'm trying to predict, your credit rating, or I'm trying to predict your distance from home. All those things can be considered to be regression. Whereas classification, are you going to pay back your loan? Or are you going to, let's say, what is this? Is this image a cat or a dog? Something like that. Or is this a cat or not a cat? That would be used for classification. So before we start, before we really get deep, as you can see, I'm giving you foundation, some elements of understanding before we learn these machine learning algorithms. Mind you, you've seen some of these already, some of these you've never even heard of. Fine, that's fantastic. But you need to understand what is a mistake and how do we quantify a mistake. And so I'm really going to start really small with what the idea is of a mistake regarding both regression and classification. So when it comes to regression, a mistake is yi minus y hat. I showed you an equation. So what? So here's just your true value. Yi is your true value minus your predicted value, which is yi hat. How far is it? There's different metrics, different measures that we can use regarding this error, but the bottom line is error. That's how far, quantitatively speaking, is our true value from our estimated value from our true value. So let's look at this particular example. A creditor wants to determine individual's credit score based on their debt to income ratio. So your credit score is 600 and you run some algorithm. It doesn't matter. Some supervised learning algorithm. It does not matter which algorithm you choose. Right? And that algorithm that you use predicts your credit score to be 620. To determine how the algorithm performed, we look at the error. So we do 600, let me give you all a second. Exactly. 600 minus 620. So the error that was found here in terms of this algorithm is minus 20. Right? It's minus 20. So you notice that I'm doing true minus predicted. True minus predicted. Now, when it comes to classification, we have to start with an example. It's a little bit tricky, a little bit different. So again, the example here is a botanist is interested in classifying species of a plant based on the petal length of the petal. So what we're going to do is to understand classification mistakes or classification errors is something called a confusion matrix. And the thing is, it is confusing. So what we're going to do is learn from example. We're going to learn from example. So if you remember from the data science video yesterday, we talked about identification variables. Let's just say we have 3 identification variables and the plant is a flower, right? And so we have these 4 flowers. All right. In reality, the true species of these flowers are setosa, not setosa. So if you look at if you looked at the data frame from today's data science video, you would have saw that we had iris. So we had setosa, virginica, and versicolor. I didn't go into detail there, but if you scroll down, you'll see those different species. But let's just say that we're going to delineate species as setosa and not setosa. As time progresses, you'll see why I'm doing this. So this is the true reality. The flower 1 is setosa. Flower 2 is not setosa. Flower 3 is not setosa. Flower 4 is setosa. Please repeat that if you need to, make that make a lot of sense. However, we use a machine learning algorithm. It doesn't matter. We just have a supervised machine learning algorithm. It does not matter, right? Just like we did with regression. And these are the predicted values. These are the predictions. Okay. So when it predicts setosa correctly, that's a true positive. It's a true positive. Good. It's true because it's correct, and it's positive because it's what we were looking for. It's looking for setosa. However, if it says not setosa, this is going to be a true negative because it's correct, but it's also not what we're looking for. So we correctly identified not what we're looking for. So this is a true negative. However, if what we're not looking for, if what we're not looking for not setosa, and we predict it to be setosa, this is going to be false. Okay, and this is what we call false positive because it's saying that we're getting what we don't want. I mean, what we do want. Sorry, we're getting what we do want, but in reality, we're not. It's not correct. It's not what we want. So this is a false positive. And last but not least, setosa. In reality, it's setosa, and we say that it's not setosa. This is a false negative. We can potentially go deeper. I think we might go deeper, but there's other metrics that can occur based on this reality. Please come to Learning Hours today if you have questions. Please have a great day.